Hi guys! Hi, I am Nikki.
Hi, I am Jackie.
Together we discuss future of design.
Hey Jackie,
Hey Nikki.
what are we discussing today?
So today we'll be talking about LLM. We'll go a little bit deeper around what's token, who decides tokenization. We'll also talk about embeddings and then a little bit glimpse about VectorDB. Then talk about open source model versus closed source model, when to use that and how it impacts a design engineer. We will talk a bit about how to be aware about LLMs and the ongoing developments happening around this space, how a design engineer can use these models, and how to identify which models should be used for their use cases.
All right, you rightly said that because in today's era, when somebody is transitioning from UX designer to a design engineer, it is extremely important to understand about LLMs. We'll deep dive into the first thing. So, what I understand from LLMs are large language models, but I've also heard about small language models and visual language models. What do you think about all these three?
So you asked about what's LLM versus SLM versus VLM. All these are models which is pre-trained on a lot of data, and SLM is a smaller, lightweight model. It's very fast, and the beauty of an SLM is it can run on devices like mobile, which makes it easy for the users to download it and use it for day-to-day tasks. Now, when it comes to an LLM, it's big. Now, when I say it's big, we should know that it's a little bit slower than the SLMs, but it can do some really complex tasks. And usually you need powerful systems for running LLMs. So you must be hearing about 20 billion parameter LLMs, 700B. So we'll talk more about it as we go deeper into the whole topic. But LLMs are trained on massive data, and it can respond fairly on any kind of questions you can ask, depending upon what kind of model is that. And the last one is VLMs. So it's a multi-model, which means it can understand images and text together. So LLMs, they're on text mostly, but VLMs are multi-model. Sometimes you must be hearing that this new Sora models from OpenAI, and then we have Nano Banana, so they can actually take images and respond to you on that. But the downside to this, training is really complex for VLMs. It's a bit more slower depending upon what kind of model is that. But that's like a quick difference between like LLM, SLM, and VLM. From a design engineer per se, how it matters is SLM, you can use it for some utilities. You can use LLM when you have edge cases around knowledge and creation, right? Then if you want to have some visual intelligence in your product or use case, then you should use VLM.
So can we go a little bit more deeper about LLMs since we started off with that?
Yes, definitely. So let us talk a little about what's an LLM. Because if you get this LLM concept right, understanding how LLM works, what's the technology behind it, then we will understand how it will impact in our decisions that we take while designing the strategy of a product. So we will see how this information will be helping a designer as we go deep into the topic.
I actually wanted to add, just for everyone to understand, is that the concept of LLM gets introduced in your project is only when you are dealing with the AI agents. So that's when an LLM comes into the picture of your project. So that's why this topic is extremely important for us to understand.
And we will figure it out as we go. Just to understand what's an LLM, it is predicting the next token. If we say like, I am going to office, so post I, what could be the different words that could be related to I? So it could be am, it could be I, where. So depending upon the context, the intent, it figures out what's the next ideal token that has to be the part of the structure.
In order to predict the next word, I'm not sure whether I got this right, but basically it is capturing the intent or the context in our user prompt, right? And then it predicts.
Yes, it predicts that. But the idea of an LLM is once you decide that post I its end, then there will be again next few words. It will have it in a library on which it will select. Now the third one is making more sense considering this too. And like that, it will keep on predicting the next word unless it feels that the structure is complete.
Yeah.
So now what's a token? That could be an interesting topic that we should know. People often think like a token is just a word, and it's not wrong, but it's also not 100% right. But in reality, it could be a word, could be a character, or it could be just a subpart of the word, which means a word can have O as one token or DS as one token. So we don't know exactly how they're defining the token. It's actually defined by the AI researchers. When they are creating the LLM, they define this tokenization, like should it be a part of the word or should it be a character? Even if they're breaking up a big word, how they should break it up. So it all defined in the complex math which these AI researchers do before starting the training of the LLM.
So what you're saying is that every company like Google, Meta, all of who have their separate LLM models, all these companies have different tokenization systems?
Yes. So for example, the Gemini models, OpenAI has GPT models, and Meta has Llama. Ideally, they would have different tokenization, and it should vary between each of them. Maybe it's same, we don't know, but it's not necessary that all of them have the same tokenization.
So Jackie, you were just talking about different words, letter, characters being a token. So I have a question that why are we not taking individual alphabet or maybe a letter or a character to be a token? Why are we taking different words or word? Why do different companies have different tokenization methods?
That's a really interesting question. And the answer is simple: language or messy. Now, we will understand this with some example. Let's take one word, which is unconventional. Now, let's see what will happen if we make a word as token, a single character as token, and if we divide this big word into subparts, how it will impact the model performance.
Let's do that.
So if we take every word as token, which means now this unconventional itself is treated as one token. So if there is a new word which is unpredictable, it never understands that un actually means something different.
Yeah.
The model will never understand that un is not a separate word. It doesn't have a meaning in itself, but it always makes sense when it's joined with another word. If there is new words, which is made connecting these pieces of word, then this model will fail. Then if there are new typos, model will get confused. What will happen essentially is we'll have some infinite vocab, which will make it impossible to train. What if we have just divided into smaller subwords, which means now it understands un as a concept, and if un is joined in any other word, it means a negative. It could have learned that. If any new word comes and model has never seen, it will get confused. Just think from a designer who is memorizing screens instead of remixing components. So he thinks like, oh, health dashboard should be around this particular component. He remembers this screens type, and that's why if somebody asks you, he will recollect that particular dashboard and just create it. He can't create something new because he's not thinking from a component per se, right? What will happen if we just take this into our second scenario? Unconventional is broken into 4 parts, which means now our model can handle new words, which means it understands ion as a concept that all is usually treated as a prefix, and it's very efficient in its vocab. Some tokenization might divide in a different way, but efficient tokenization helps in balancing the model.
All right. This also takes us to one more note that if all these companies, they train their model with each individual vocabulary, I think it will take decades to train a model.
Yeah, decades is like a big word. We don't know how much time it takes, but certainly it will take a long amount of time to train it, because that's the third scenario. So what if it's a single, it's like word by word. So let's say for unconventional, it's un and like that. So every word is treated as a token, which means effectively it's like too slow. It will also lose its semantic meaning, and it's very hard for the model to learn the relationship For example, if you see here in this scenario, it knows that un is related to convent and in is also related here maybe to some others. But how tough will be to understand like u is connected to a billions of words because every character is a token.
Yeah.
Just to sum it up, how it impacts our design engineer is if we treat a whole word as a token, it's like one big Lego block. Now it's so rigid because you can't break into small parts if you make one big block. Same thing if you just treat a big word into one token. Now, if you take character level, it's like we are treating grains of sand, which means it's too messy now. It's so tough.
Yeah.
The last one is like the subword. Now, this is more balanced because you can treat it like a Lego brick, which means you can drive some balance. You can take a break and then you can maybe remove this, maybe add a different break. But if it is a big block, you can't do anything out of it. So tokenization is like choosing the right Lego size, if you sum it up.
Right. So what you mean is that tokenization directly affects on different aspects like speed, cost, accuracy, and ability to understand new words.
Yes, you're right. So it will impact the LLM. For example, if you use a larger token, which means you're using every word as a token, it will be more faster, which means if a user queries it out, it can immediately give you an answer because your tokens are large and the cost will also be reduced to train. But the accuracy will drop, which means if you ask some complex questions, it will not be able to answer you because it doesn't know those smaller meaning, and it will also find it tough to understand new words, which means it will just hallucinate at certain things. On the flip side, let's say you have defined tokens as at very granular level, then what will happen is your cost to train will be pretty high, and which also means your latency will increase when the user queries because it will reason more. Your accuracy will definitely improve. Your speed of query will definitely increase, and your ability to understand new things will increase. But again, you will be spending a massive amount of dollars just to train it and to run it. But if there is a balanced approach, then what will happen is you will be fairly able to understand new words. Your accuracy will not be like the granular one, but still it will be good in terms of utilizing for any kind of product. It's not bad, we can say, but you will have a balanced impact on your cost, and your speed also will be faster. So that's why it's highly imperative for the AI researchers to define best tokenization logic for their LLMs because it directly impacts the outcome of the LLM. And one thing I want to just add here is that this tokenization, once an LLM is trained, you can't change it again. If you want to do it, you have to create a new one.
So that's why we have different models like OpenAI and these all companies, they release different models at each time.
Yeah, I mean, they might have different use cases for that. But one thing we know for sure is that once a model is trained, if you want to deploy a new method of tokenization, you have to end up creating a new one.